Meta has announced a new model series, Llama 4, and here is all you need to know about it. First of all, there's 3 different models, which I represent here by these 3 different characters. You'll see more of them in the presentation. Enjoy. Let's give you a little overview of Llama 4 generally and what you're going to see in this presentation. First off, there's a system prompt suggestion by Meta, which reads, "You are Llama 4, your knowledge cutoff date is August 2024, you speak Arabic, English, French, German, Hindi, Indonesian, Italian, Portuguese, Spanish, Tagalog, Thai and Vietnamese. Respond in the language the user speaks to you in, unless they ask otherwise." See if you can remember all of these languages until the very last slide, and watch till the end for some Q&A which I have come up with. And I'm always open for your comments, your questions. Please just drop them in the comments below and I'll make more videos and try to answer and respond, of course, with what I know and what I can support you in. So in this video we'll talk about the 3 Llama 4 models. We will discuss what mixture of experts means, because that's a new modern approach which Llama 4 is using. We will see how they stack up against the competition. We'll explore what type of hardware they will run on. And of course, I'll share with you where you can download it. Before we get to the Q&A, and as the Llama says, watch till the end. Let's have a look at the 3 different Llama 4 models. They're known as the Scout, the Maverick and the Behemoth. With Scout going first, it's a model which has 109 billion of parameters in total, and of these 17 billion of parameters are active. It has 16 experts in total and uses a context, or can work with a context length of up to 10 million tokens. I've highlighted this particular bit because this is something which Meta is really proud of, and it's a really big context length. We will explore the context length and what mixture of experts means in a little bit. But for now, the long context length means that it's really good for putting lots and lots of content and information into it. So for example, as a use case, you can summarize long documents. Also, Meta says that it's best in class on image grounding. We will explore what image grounding means in a little bit as well. Finally, they have a strong claim, which is that Llama 4 Scout offers a stronger performance than all the previous generation Llamas. Let's see how that will stack up when we have a look at the competition. Mixture of experts. This is a modern approach. Background of this approach is the larger models get, the less, let's say, capable small computers are at running and executing these models. You will need bigger and bigger and bigger hardware with more and more memory bandwidth, which is a problem of itself. Knowing and realizing that, similar to human experts, not always all of the knowledge and the entire 2 trillion parameters or whatever are needed actually to come up with the next token, they have created a router, and I will share a more technical diagram in a bit, where you can determine at runtime which expert the token is going to, or the input is going to be routed to, so that the right expert will respond. In a bit, there's no point if you, let's say, you are asking a question about art, you want an art expert to respond and not the math expert, or let's say the history expert. So there's different experts, and in the different models there's a different number of experts in it, which is interesting of itself. Let's have a look at this more technical diagram. So basically, for each token there is a decision which expert it's going to be routed to. So these are the 16 experts of Scout, Llama 4 Scout, and there's always a shared expert. So some tokens, a shared expert is always seeing everything, and then for the other part, so basically it's kind of split, and it goes through the shared expert, and then it also goes through a router which will then determine expert 0 to expert 15. By the way, that's basically programmer style or informatics style for giving 16 experts. You start at counting with 0, because why waste a perfectly good number, right? So that's the way this works, and this leads to very interesting economics concerning memory bandwidth. Basically, you need to have more memory because you need to house all the experts in the memory at the same time. You can't load them runtime because each token might be routed to a different expert. But you do not necessarily need to load the entire content of the entire model or all the weights at once. If you've watched some of the previous videos I've done, there's this calculation where you can roughly estimate how fast the model will be, and that is based on memory bandwidth. And memory bandwidth is a huge challenge for different computers. Macs are quite good at it, but you know what's even better at it? It's high-end hardware. We will also have a look at hardware and what you can run it on in this video a bit later. Basically, just as a takeaway, mixture of experts means you can run models with a lot of RAM but less memory bandwidth, which means that you will get decent performance on lower class hardware with lower memory bandwidth, and you don't need extremely expensive HBM3E memory necessarily in order to run this. Just as another explanation or visualization of why that's a good thing, if you look at this, let's say you're trying to load all these cars, so imagine the memory lanes or the memory bandwidth as these 4 lanes of cars, and if there's too many cars on it, the road will get congested, so they will not be able to move fast to the destination which you need. In this, on the other side, the golden side, there's a huge parking lot, so a lot of these cars are not moving at all at a single time, but there's enough space for all these cars to move at enough speed so that actually the response of the model will be faster. Let's have a look at Llama 4 Maverick, this character here, wearing signature sunglasses. Actually, Maverick reminds me of the character of Tom Cruise in Top Gun, so that's how I prompted ideogram in order to create these characters. Llama 4 Maverick has 400 billion parameters in total, but at the same time there's only 17 billion parameters which are going to be active. That's similar to Llama 4 Scout. And in contrast to Scout, of course, it has many more experts, 128 experts in this case. Also, the context length is reduced. But the interesting bit which I want to touch upon, because we just discussed mixture of experts, because the active parameters of this model are of the same magnitude, exactly same magnitude, 17 billion, this basically means you need more RAM to load Maverick, but it will perform at a similar speed to Scout. It's basically just really the RAM difference. What they are talking about as a possible use case for this model is image and text understanding, using it as a general assistant or a chat, and for creative writing. They're saying it's the best multimodal model in its class. So that's all you're going to get in, and which is kind of downloadable and currently released, because Llama 4 is still in preview, the Behemoth model. That brings up another question. What is multimodal? Now, multimodal means that previous Llama models were just looking at text and text tokens, and they could answer in text. Multimodal means that you can also put in images or videos or other types of content. In the particular case of Llama 4, it will definitely mean images and probably also videos. So you will be able to actually query the content which you put into it and ask questions about the image which you put into it. And it's not just one single image, it's actually 5 images, possibly even more, but I think they claim that up to 5 it's been tested, and it's more reliable up to 5 images at the same time, and you can ask questions about these images. What about Behemoth now? So Llama 4 Behemoth is still training. It's a huge model, and it needs a lot of time to train and to become better at what it does. It has nearly 2 trillion parameters, of which 288 billion parameters are active at the same time. Again, similar to Scout, it has 16 experts. We do not know how big its content length is. And as a use case, Meta says that it's the teacher model for distillation of the smaller models. So possibly there's going to be more models distilled out of Behemoth as it gets bigger and better and more trained. And possibly there's not going to be many use cases for Behemoth on its own, because it just needs massive hardware to run. It's very expensive to run, it needs lots of energy. So possibly it will be just trained and used for very specific, maybe internally at Meta, but also more for very specific use cases, such as being a teacher model for distillation. Generally, you want to use kind of the smallest model which you can get away with good quality. Meta also says that Behemoth is among the world's smartest LLMs. The next question we're going to look at is, what is image grounding? Image grounding basically is not just guessing about the image, but for the model to understand which area of the image the user is talking about, it will be able to align these user prompts with relevant visual concepts and anchor model responses to regions in the image, which means it will be able to say, okay, like this is what you're talking about, and these are the relevant bits. On the homepage of Meta, they also have an example with birds. So there's a couple of birds sitting next to each other, and you're saying like this bird and that bird, what are their names? And then it gives you details about these birds and can also circle them. Or no, I think it's this way, that the user circles the birds and then asks questions about them, and then Meta identifies these birds correctly, or the Llama models identify the birds correctly and answer questions about them. So this is quite nice, because it basically allows you to think more like a human would, right? So you could show it a picture, maybe circle some things or describe some things, and it will be able to identify what you're talking about, or circle the things which it thinks are the best fit. So you could have it search through images, or you could ask questions about, let's say, a particular dress which you're seeing in an image, and the color of it, and what might go well with it, and so on. Meta says that the model has been trained in a special way in order to amplify this and to make it better. So they highlight image grounding as one of the new features of the Llama 4 series. Finally, long context. So remember, we discussed the 10 million context of capability of Llama for Scout, and on their homepage they give this example of what is the special magic Lagos number, and this number is whatever this. They have taken a long text and just inserted this somewhere randomly in this. They give it to the model as one single input as the context, and then they ask a question of it. Now, they do not claim that this is perfect, but considering what 10 million tokens really are, this is quite amazing, that it's possible for the model to find out what you're talking about in this huge context. I would say it's a superhuman ability here. Just to give you a better sense of proportion, 10 million tokens are 7.5 million words. 1 million tokens is about 750,000 words. A typical novel will have 80,000 to 100,000 words. So if we're talking about the context length of Llama 4 Maverick, there's this book, there's 7 books on the left side. So it's actually able to take in several books worth of input context, and that could be like specialist books which you're interested in, which are relevant to the particular question you're asking. This could be a lot of company documents which you're putting in. Remember, Llama 4 is also something you can run on your own hardware, right? So basically you will be able to actually work with sensitive data which you put into the model because it runs locally. You do not necessarily have to run a cloud service. And for the Llama 4 Scout model, you will be able to put in 10 million tokens. Now, is this as big as one library? No, it's maybe 100 novels, something like that, 70 to 100 books. And these would fit on a decent sized bookshelf, maybe similar to the one in the picture. Basically, as a takeaway, this is huge. It's a huge context. You can put in a lot of information into it, and Llama has really stepped up the game compared to previous models, but also to competitors. Here's a reminder which the 3 different Llama characters are showing you to subscribe to my channel if you're enjoying the content so far. And this will really support the channel and keep me going and creating more of these videos. Again, also, if you have any particular questions as they're coming up, just drop them in the comments below, and I'll do my best to go through them, do videos, maybe answer questions I feel qualified answering. And with the others, I'm going to qualify myself to answer them sooner or later. So this brings us to the question of how do these models perform against other established models? How good are they? And this really depends on who you're asking. If you are asking Meta, of course, they are excellent and they have a very high performance. So if you look at this chart, this is an interesting chart because it shows you the cost versus the ELO. ELO is the strength of the model, and this is on LM Arena, which we're going to look at in a bit. And basically, Llama 4 Maverick is cheap, that's what the chart is suggesting, but also it's very, very good, so it convinces users to rate it highly. Whereas GPT-4.5 Preview is very expensive and not even quite rated quite as well as Llama 4 Maverick. At least that's what the chart is suggesting here. Let's have a look at more data. So Llama 4 Maverick is being compared in different benchmarks. As you see, they are comparing themselves to Gemini 2.0 Flash, DeepSeek version 3.1 and GPT-4.0. DeepSeek R1 is not on this chart, and I'll get a bit more into why it's not being compared against DeepSeek R1 in the questions and answer section at the end of the video. Note the very low cost per 1 million tokens input and output. This of course kind of depends on what hardware you run it on, and they are comparing to what their competitors are charging for their cloud offerings. There's different tests depending on whether you're interested in image reasoning, image understanding, coding, reasoning and knowledge, or multilingual texts. Note they highlight where they feel the best value is at. So in this case, Gemini 2.0 Flash is cheaper, and that's fair that they put it on here, but it's also a bit worse than their model for different tasks. DeepSeek version 3.1 does not have multimodal support, so they're not comparing these. Now, DeepSeek is actually better in live code bench, which is something we will see a bit later as well in some of the user feedback. Then it's also better on MLU Pro, but worse on GPQA Diamond. Now these are tests which test different aspects of a model in a different way, which I feel would go beyond the scope of this particular video. If you're interested in me explaining more what these individual tests mean and doing a separate video on that, please drop that into the comments below. Let's have a look at how Llama 4 Scout compares and what it compares to. So in particular, they're comparing to their previous models as promised. They say that Llama 4 Scout is better than any previous model which they have deployed, including the 405 billion parameter model, which they have created with Llama 3.1. They also compare it to Llama 3 with 27 billion parameters, Mistral 3.1 with 24 billion parameters, and Gemini 2.0 Flash Lite. Now keep in mind, Llama 4 Scout is bigger than Llama 3, Mistral, because it has a mixture of experts model. Less parameters are active at the same time, but more I personally feel that these comparisons here are a bit off. Not the ones with the previous Llama generation, but with Llama 3, Mistral 3.1 and Gemini 2.0 Flash Lite. Specifically because, yes, the individual parameters on Llama 4 Scout are smaller when we're looking at the activated parameters. Remember, that's 17 billion active parameters. But in total, we are looking at 109 billion parameters, which is significantly more than Llama 3 or Mistral 3.1 have. So I would say these results here should be taken with a grain of salt. Now, another point, of course, is that the previous Llama series did not have multimodal support, so that is new, and that's why we are not able to compare here. The live code bench, it also is better than these other models, and better, of course, than Llama 3.1 405 billion, which shows that they have actually worked and created a better engineering. Now, the other important thing here is that the context window is 128,000 tokens on the previous models. So that's something they have significantly improved and pushed. As you see, also these models, they're trying to kind of differentiate on certain features and become better and compete against each other, which of course creates better results for us, the users. Let's have a look at Behemoth. And this is a preview result, of course, because as we already mentioned, it's still in training. So they are comparing it to Claude Sonnet 3.7, Gemini 2.0 Pro, and GPT-4.5. Of course, another model is in preview called Gemini 2.5 Pro. So maybe because Behemoth is still training, it would have been a good thing to compare it to Gemini 2.5 Pro, which Meta did not do. But we will see a little bit more in a couple of next results. And just quickly here, again, it seems that the Behemoth is really good at maths, with 95%. Here is also excelling in some other categories and is also fluent in many different languages as a multilingual MMLU. Finally, is there actually any parameter which they chose where Behemoth is performing worse? Doesn't look like it. In every category it's better. Again, since they're listing some tests and they're not listing some other tests, it would be nice to know how they performed in these tests. I will possibly do, if you're interested, a separate series on that and dive a bit more in depth on the tests. Comment below if that's a video you would like to see. With a chatbot, they have, with LM Arena, they have a leaderboard here. Basically, this works by having users choose between two model responses and saying which one they prefer. So Gemini 2.5 Pro, as mentioned before, is actually the leader of this board. And the interesting bit is that Llama 4 Maverick comes in closely behind it. And then it's ChatGPT 4.0 latest, and ChatGPT 4.5 preview is actually worse. But there's also critical voices like this here. Dr. Karminski is saying that they're incredibly disappointed with Llama 4. And there's a specific test which they ran. It's about some bouncing balls. And they actually have a full series, which I'm going to show you, where they say that the performance is worse and maybe more roughly on par with Qwen QW 32 billion in terms of coding ability. And they're comparing it here with a 402 billion model. Let's have a brief look at the QW 32 billion. And as we see, it says here that it is the reasoning model of the Qwen series. Now that is something we have to keep in mind, that the Llama 4 series, these are not reasoning models. They do not think, they do not take some time and generate tokens in order to go and step by step through processes, but they just give you an answer straight away. It is harder, of course, to come up with a very good answer immediately than to think through it. So that might explain some of the worst performance which they're seeing in these tests here in particular. So what they're doing in these key cores, and as you see, Karminski is one of the contributors here, K-Core's LLM Arena, they are creating different, using different models to create code, and then they are judging this code by how it looks like, basically by a human in the loop. This is the results which they have seen, and they have said that Llama 4 Scout, for example, is here, and Llama 4 Maverick is here. So they are performing similar to Qwen on this particular test. So possibly depending on the type of test you might want, or on the type of task, you might want to look into different tests which are applicable to these models and then choose the right ones. By the way, Gemini 2.5 Pro comes out on top here as well. That gives you a first taste of how good these models are. Basically, again, to summarize, Meta claims they're much better, but it depends on who they pick as a comparison, and we will see more real-life results coming out, and I will do more videos on this topic. Now, if you're convinced that this is a model you want to try, of course the next question on your mind would be, will I be able to run it? What kind of hardware requirements do we have? Do we need a rack of servers, same as the Scout is standing on here in this picture? Or are we able to run this maybe on a Mac? Let's see. So for Llama 4 Scout, we have 109 billion total parameters, of which 17 billion are active. If we calculate the necessary RAM, and that's a kind of rough, easy calculation. Now, the total RAM required will be bigger than that because you have to fit the KV cache in. But as a first rule of thumb, you can just take, if you want to do the model in the original parameter size, usually it's BrainFloat 16, you would be able to double the number of parameters and then calculate the gigabytes which are required. So if we want to run the model in its full glory, with Scout we need 218 gigabytes. If we go down to int4, because that's something which they are suggesting actually, and they have code which allows you to go down to int4 runtime, on the fly int4 quantization they call it, you would need about 55 gigabytes. The bandwidth which is required is another important bit. And I'm going to go through these things for Llama 4 Scout first, and then we're going to talk about Maverick and Behemoth. So for 34 gigabytes per token with BrainFloat 16, we can derive that from the active parameters, because these are active at a single time. So all the parameters need to be loaded into memory, but only the active parameters are then streamed into the GPU and calculated and used to generate the next token. So that's why the bandwidth requirements can be calculated from the active parameters. And again, at BrainFloat 16, it's double the active parameters, so it's roughly 34 gigabytes per token. Now I've put a plus behind it because also you will need to stream the KV cache and possibly also some others, maybe even system overhead. So this will be, the theoretical maximum you can achieve here will always be higher than the actual token per second rate, which you will get. And the bandwidth per token on int4 quantization, so that is actually 4 times less than the 34 gigabytes. Or if we take the 17 billion parameters and divide by 2, because 2 parameters fit into 1 byte, in that case we will get 8.5 gigabytes per token of bandwidth. So taking this bandwidth allows you, if you know the memory bandwidth per seconds, you can divide by this and then get the number of tokens per seconds which you need, which you will be able to generate. Meta recommends a single H100 GPU with on-the-fly int4 quantization. And that's also why they suggest int4 quantization, because this single H100 GPU has 80 gigabytes of RAM. At the bargain price of $30,000, you'll be able to run Llama 4 Scout with an int4 quantized model. Now, for Llama 4 Maverick, with its 400 billion parameters, you still have the same memory bandwidth as we just discussed, so because it still has 17 billion active parameters, but the total RAM increases significantly, and that's interesting. Here we actually require 800 gigabytes if we want to fit the entire model, or if we want to go for floating point 8, we still have to fit 400 gigabytes, roughly. Actually more, again, because the KV cache requires RAM as well, and fast RAM, ideally GPU RAM or shared system memory. They recommend an H100 DGX host. If you quantize the model in FP8, you'll be able to fit it in there. With 640 gigabytes of RAM, that should work at a price tag of roughly $375,000. With Llama 4 Behemoth, we have nearly 2 trillion parameters, of which 288 billion parameters are active. It requires a total of 4 terabytes of RAM if you run it in BrainFloat 16, or 2 terabytes if you run it in floating point 8. There's requirement of 676 or more gigabytes per token for BrainFloat 16, or 288 plus gigabytes of token for floating point 8. Meta does not give any recommendation for running Behemoth. Now, keep in mind, it's still training, it's getting stronger, bulkier, and so on, but basically the type of hardware you need to run this on in order to not get extremely sluggish performance are clusters in the cloud. That's it, right? So you can not run this model on local hardware and expect decent performance. And this also, yes, this also includes exoclusters, because the network connect between the different Macs, for example, will just not be fast enough for this. So what about hardware which you can run locally and afford locally? I've picked 2 examples. Please comment below if your favorite hardware is missing and I should have included it. Mea culpa, I will create a different video for this and will link it to your comment. Llama 4 Scout. Again, what we need to do is we need to do 2 things. We need to look if the model fits into the RAM and at what quantization it will fit into the RAM, and then what memory bandwidth it will need in order to run on this hardware. And then from the memory bandwidth per token, we will be able to calculate or roughly estimate how many tokens per second, how fast this model will be. And anything with 10 to 15 tokens should feel okay. anything below 10 tokens will feel a little bit sluggish, at least not real time. Now the good news is on a Mac M3 Ultra Studio, if you run the model in RainFloat 16, you should get a performance of 10 to 15 tokens per second. And the same is true for Llama 4 Maverick. Now, actually, I made a mistake in this slide. Can you spot it? Yes, the mistake is the full model will not fit into the Mac because the Mac has 512 gigabytes of RAM. So then you can expect the floating point 8 model to run at roughly double the performance, so maybe 20 to 30 tokens per second. So this actually needs to be fixed. Let me actually do this. So if anyone wants to take a screenshot, please take a screenshot from here. So the floating point 8, the Llama 4 Maverick will be able to fit into the Mac, but at floating point 8, and interestingly enough, my prediction is it will run faster than Scout, but only if Scout, of course, is loaded in BF16 at a higher precision. Now that's going to be a very interesting comparison. Will Scout at BF16 actually beat Maverick at floating point 8? A very interesting question. My feeling is that if you want to run a Llama 4 on the Mac and you've got the RAM, that Maverick is the better choice, even at floating point 8. Simply because it has more experts, it's more nuanced, it has more parameters in total, of course. It will be able to route to more experts, so my guess is that Maverick is going to be the better model. Anyone with a Mac Studio who can try it and who has tried it, I would be very happy to hear about your results and elaborate on them more. Here in Germany, we're still not able to get the 512 gigabyte Mac Studios. We still need to wait a bit. Then what about Behemoth? Now, I jokingly put it needs an exocluster, but really it will be too slow probably for real life use. And I mean, Meta will probably release more models. We'll see what happens, and well, even if they released a model which had smaller experts, because it really requires a lot of memory bandwidth, I still think it would be quite a burden to try and run this locally. But maybe, hey, you know, like, if someone wants to go for it and wants to try it and it does get released, see what happens, right? The expected performance on DGX Spark, in contrast, is lower. Simply, and also please note that I'm comparing BF16 to floating point 8 here. So the Mac is faster at a better precision. Because the DGX Spark has less memory. It does not have enough memory to fit the full model. It has only 128 gigabyte of memory. So you would expect performance on Llama 4 Scout of 5 to 10 tokens per second as per my calculation, simply because of its memory bandwidth of 273 gigabytes per second. My general assumption is that the compute hardware, so the actual cores on the DGX Spark, are better than the Mac M3 Ultra, so that they're more capable and faster, but that the memory bandwidth kind of severely constrains what it can do. And then, of course, bigger mixture of experts models might not fit into the DGX Spark, where we will comfortably fit into the 512 gigabytes of RAM on the Mac. For Maverick, again, for DGX Spark we would need a cluster, and for Behemoth also a cluster. Now, I think it's more something DGX Station-like, which we'll look into a bit. As a comparison, for the H100, which is the recommended type of hardware to run the Scout on, for an in4 quantization, which is all you can fit the model in on the H100, you will be able to get between 150 to 190 tokens per second for a single user. Now, if you combine multiple user requests, then you can do even more, but that's beyond the scope of this video. DGX Station, the parallel computer the other computer which NVIDIA announced, has a memory bandwidth of 8 terabytes per second. Now, this is an important thing, an important point to note. This memory bandwidth of 8 terabytes per second is for the HBM3E memory, for the high bandwidth memory, which is closely linked to the GPUs. And we only have 288 of it on the DGX station. In a total, it has 784 gigabytes of RAM, but for the other RAM, it will slow down to 396 gigabytes per second access speed. Even for a mixture of experts model, that will mean that if you run Maverick on it, I expect the model to perform, because if we have to really select these experts randomly, it's something like 20 tokens per second and floating point 8. Maybe it will be higher, maybe it will be 30 tokens per second. Let's see. For Scout, which fits entirely in BF16 into the HBM3E memory, we will have a really nice performance of 175 tokens per second. Again, let's see whether my predictions will hold true. These are calculated on theoretical memory bandwidth figures, not taking into account KV cache too much. I've taken a rough estimation of what I know and what I believe NVIDIA hardware to be capable of saturating the memory bandwidth. Basically, we'll see what comes out of it. Here, I'm asking for your opinion about a very new idea I had while I was creating these videos. I was thinking, because if you're purchasing an expensive car, let's say, something like this Lamborghini in the back, which these three guys are test driving, yeah, you would want to test drive it, right, before you fully commit to it and to this really expensive hardware. And I was thinking, you know, such a Mac, which comes in at, let's say, $10,000, or a DGX Spark coming in at $3,000 to $4,000, maybe it's something you would want to rent over the internet from hosted in a data center and run it at very high speeds. So I'm imagining something like a 10 gigabyte Ethernet uplink to the internet, so you can download models quickly. You can test and run those models and see if what you're looking to do with this type of hardware is actually a fit. And best case scenario it is, and worst case scenario you lose much less money because you only pay for this one service access. Comment below if you would like to help me out to build such a service, in the sense of if you think this is something you would like to see, you would like to test, and also if you have an idea of how much it would be worth to you and what types of you know, conveniences you would expect, where you would want to use this, how long you would want to use this in order to get a good feeling for the system, and how much you would be willing to pay. I would be very happy about your comments, because one thing I've decided as an entrepreneur is not to try and build something before I've actually heard and consulted people who I'm building for. I know how I would build this for myself, but I actually care more about your opinion than my opinion here. Because ultimately, if no one buys it when I build it, it's a mistake I've done before. There's no point in doing it. So thank you very much. And also, of course, if you have an opinion about this video, please feel free, comment below. All comments are welcome to me. Critical ones, positive ones, encouraging ones. People who say that I think there was a comment previously where they said I am doing a very slow presentation. I'm trying to up my game there as well, so please just write anything which comes to your mind. And again, if my test drive idea appeals to you or it doesn't appeal to you, please comment below and let me know. Now we come to the next part. It will run on my hardware. Okay, that's something you think or you're confident about. You've gone through the calculations, the estimations yourself, you feel it's something you want to give a shot, or you just have H100s lying around and you need to use them. So where can I download it? And it's easy. There's 2 locations. You can download Llama 4 on huggingface.com and llama.com. Note that you will need to agree to a user agreement, and as mentioned several times already, Behemoth is still training, so you will only be able to read about it but not download it currently. There's a couple of different models. Probably the one you want to get is the instruct one, because that follows instructions and it's more chat-like. Let's get into a bit of Q&A. Is this a reasoning model? No, it's not. It's a kind of normal run-of-the-mill model. It's not built as a reasoning model. Is Maverick also multimodal? All of these models are multimodal. Will it support non-English languages? Well, if you remember one of the first slides we had, yes, they are optimized for this, and especially Maverick is. There's 12 languages in total, which again, as I promised you, I'm going to repeat here. It's Arabic, English, French, German, Hindi, Indonesian, Italian, Portuguese, Spanish, Tagalog, Thai, and Vietnamese. There's a couple of flags behind the guys here of what is supported. I wonder actually how they came up with this choice of languages in particular. Tagalog is a language I actually had to Google because I hadn't heard of it before. The others seem to be quite popular, of course, and I think should cover a lot of the world. Now, notably Russian, for example, is missing from this. What type of local hardware will I be able to run this on? You need lots of RAM, and you basically need lots of RAM. High bandwidth would be good, but thanks to the mixture of experts, it's okay. You don't need that much bandwidth to run it. For example, a Mac Studio M3 Ultra 512 GB might do perfectly well for this type of model. Can I use this commercially? Yes, you can. But you must show that you are building on top of Llama, like build with Llama, somewhere on your website, documentation and so on. Please read the details in the agreement. And you also must name derivative models, Llama something. And finally, there's a caveat. If you have more than 700 million monthly active user companies, or you have more than 700 million monthly active users, you're a company which has this amount of users, you need a special license. Also, I want to work with you. Reach out to me by a comment and we'll take it from there. Does it make sense to run this on several GPUs? Yes, it does, absolutely. If you have several GPUs, you can spread the model across it. I think this should play well with the mixture of experts model. And I'm thinking of something like RTX 6000 Ada generation GPUs or the upcoming Blackwell generation GPUs. Possibly it will be even better to cluster it in that way than, for example, use the DGX Spark. Your mileage may vary. We'll see, and I'll do more videos about this when I actually get a DGX Spark into my hands. Thank you for watching. If not all of your questions were answered, just drop them below into the comments. Subscribe and ring the bell so you will be notified when new videos come out, and you will be up to date on all the most recent developments in the world of AI, machine learning, and how it can benefit your business. Thank you for your time in watching this. Now this is nearly 50 minutes long. I really appreciate it. And again, I'm very open for all of your comments. Please drop feedback onto my suggestion for test driving the model or the car, or actually the hardware, what it's about, into the comments below. And I'm going to say goodbye and ciao in this place until the next time, so we still stay under 50 minutes.